Okay, good morning, children. Today we are doing some question answers from NCERT exercise. So, question and answers on thermodynamics. So the first question is, we are doing 6.7 of NCERT. It says that in a process 701 joules of heat is absorbed. 701 joules of heat it is said it is absorbed by a system, and 394 joules of work is done by the system. We have to find out what is the change in internal energy for the process. That is, we have to find change in internal energy. So this is the question. So if we write this in symbolic form, Q equal to 701 joules, and according to sign convention we know that heat absorbed by the system is considered to be positive, heat released by the system is considered to be negative. Since it is absorbed, so it will be plus. And work, it is given 394 joules. 394 joules, and according to such convention for work, work done by the system is negative, work done on the system is positive. So since it is work done by the system, it will be negative. And remembering the relation for first of thermodynamics, we know first of thermodynamics means delta U is equal to Q plus W, and putting the value of this quantities, 701 minus 394. This much joules will be the answer. Now we will do question number 6.8 of NCERT. Okay, this question says that the reaction of cyanamide with dioxygen was carried out in a bomb calorimeter and delta U was found to be minus 742.7 kilojoules per mole. So straight away delta U value is given. It's minus 742.7 kilojoules per mole. So this is given, and this is happening at temperature 298 Kelvin. Calculate the enthalpy change for the reaction. That means we have to find this quantity they are asked to find, and this quantity we have to find for this process. The process is given NH2 Cl gas plus 3/2 O2 gas arrow N2 gas plus CO2 gas plus H2O liquid. So for this process or for this reaction we have to find delta H. Delta U is given. Okay, so children, you know the relationship between delta H and delta N. It was we have discussed the relation between delta H and delta U. The relation is delta H is equal to delta U plus delta Ng RT. This was the relation where this thing was number of moles of product gaseous minus number of moles of reactant gaseous. So straight away let us put this value minus 742. Now it is given in kilojoules. Let me write it down in joules, the value in joules. So to make it in joules we have to multiply by 1000, and if you multiply by 1000 it will be this. So this much kilojoules in joules, it is this. Okay, plus delta Ng. Delta Ng is this is 1 plus 1 2. We will not consider this one. So 1 plus 1 2 minus this is 1. This is 3/2. So minus 1 plus 3/2. So this is product mole, this is reactant moles, this minus this, and R, the value of R in joules it is 8.314, and temperature, the process is happening at temperature of 298 Kelvin. So into 298 we have to do. So this is the answer. So I am writing one more step, minus 742,700, and this is 2 plus 1, 5/2. 5/2 means 2.5. 2.5 means 2 minus 2.5, it will be 0.5, minus 0.5. So minus 0.5 into 8.314 into 298. So you simplify, this is the answer that will come in joules. So this is the value of delta H, this much joules. And if you want to report the answer in kilojoules, because if it is given in kilojoules, if you want to report the answer in kilojoules, whatever you get here, you divide again by 1000, you get the answer in kilojoules per mole. So, children, this is a very easy question. Now, we will do a numerical on heat capacity. We will do a numerical on heat capacity. Okay, so now question 6.7. It is said calculate the number of kilojoules of heat. So we have to find heat. We have to find heat in kilojoules. This is the question mark. To raise the temperature of 60 gram of aluminium. So mass of aluminium is 60 gram aluminium, and we have to raise the temperature of aluminium from 35 degrees Celsius to 55 degrees Celsius. We want to raise the temperature of aluminium from 35 to 55 degrees Celsius, and given molar heat capacity of aluminium, it is given to be 24 joules per mole per Kelvin. 24 joules per mole per Kelvin. So we have to find out heat. So what is the heat that will be required? Q we have to find. Okay, and here since it is aluminium, we need to know the atomic mass of aluminium. Atomic mass of aluminium is 27. This will be given in the question. Atomic mass of aluminium will be given. Okay, this is molar heat capacity 24 joules. Now we know heat lost by system or gained by system, heat is mass into specific heat into temperature change. This is heat, and this relation will become number of moles into molar specific heat into change in temperature. If we want to write it in moles, it will be like this. Okay, now number of moles, we have 60 gram, so 60 by 27 is the number of moles. Okay, molar specific heat is given is 24, and the change in temperature 55 minus 35. Remember, change in temperature, whether we do it in Kelvin or Celsius, change value, it will be same. We need not convert to Celsius. It's given in Celsius. We need not convert in Kelvin, because delta T value, you should remember this thing, delta T value in Kelvin or in degrees Celsius will be same. Okay, so this is the answer you will get in joules, and since in the question they have said to report the answer in kilojoules, so whatever you get, you divide in the last by 1000, then you get the answer in kilojoules. Okay, now one last question for today. Okay, that is, we will do question number 6.10. Okay, now 6.10. Calculate the enthalpy change. So we have to find enthalpy change on freezing 1 mole of water. So we have 1 mole of water. And we have to change its temperature from 10 degrees Celsius to 10 degrees Celsius of water. We have to change it to minus 10 degrees Celsius. So naturally it is ice. So for this process we have to find enthalpy change, and what else is given is delta H fusion. Enthalpy change in fusion is given is 6.03 kilojoules per mole at 0 degrees Celsius. This is given. And what else is given is Cp for H2O liquid. It is given 75.3 joules per mole per Kelvin, and Cp of water solid, it is given 36.8 joules per mole per Kelvin. Okay, so these are things given. So we have 1 mole of water at 10 degrees Celsius. We have to change it to ice at minus 10 degrees Celsius. For this, what will be the enthalpy change during this process? We have to find out. So what are the things given here? Enthalpy change of fusion. It is 6.03 kilojoules per mole at 0 degrees Celsius. Heat capacity of liquid water is given. Heat capacity of solid water is also given. Okay, now we can divide this change into steps. We have to divide the changes into steps. What are the steps? I'm telling you. We have water at 10 degrees Celsius should be first changed to water at 0 degrees Celsius. Water, which is liquid, should be changed to water at 0 degrees Celsius, which is also liquid. Then this will be changed to ice, solid, at 0 degrees Celsius. So this is the change that we have to do. Water at 0 degrees Celsius to ice at 0 degrees Celsius, and then we have to get ice, which is again solid, at minus 10 degrees Celsius. So this change can be divided into these steps. So we have to get delta H1 for this step, delta H2 for this step, and delta H3 for this step, and we have to add this, we get the answer, because enthalpy is a state function. So on adding this value we'll get this one. So we have to find out this delta H1, delta H2, delta H. First delta H1. Delta H1, what will be the value of delta H1? Since molar heat capacity of liquid water is given, so delta H it is number of moles into molar heat capacity into delta T. So now number of moles of water, it is 1, it is say. Molar capacity of liquid water, it is given 75.3, and change in temperature, when we change from 10 degrees Celsius to this much, the change will be final minus initial, so 0 minus 10. So this much will be the answer, minus this is 10 into 10, this is 753 joules. So this much joules is the answer. Now for next step, delta H2. And here you see delta H2, temperature is remaining same. So we have to use this quantity. Fusion, here fusion is taking place. I mean this step, from if you go from ice to water, it's fusion taking place. So we have to take this value here. So delta H2 will be, since we have 1 mole, and this is for 1 mole only. So delta H2 value will be 6.03 kilojoules. That is 603 multiplied by 1000, and 20 will go out, this much joules. And finally delta is 3, and here one thing, since here water to ice, heat will be released, so this value will be minus. And coming to delta is 3, again we have to use this relation, number of moles 1 into molar capacity. This is solid ice value is given 36.8, and into change in temperature. So change in temperature will be minus 10, minus 0, so it will be minus 10. So it will be minus 368 joules. So we have found the value of delta H1, delta H2 and delta H3. So the final answer will be sum of all this, okay, so sum of all this, and that will be the answer. So now you see answer is coming in negative. It means that when we carry out this process, when we change water at 10 degrees Celsius to ice at minus 10 degrees Celsius, okay, heat is going to be lost by the system. And heat lost by the system or heat released by the system, we know according to sign convention it should be negative. So that's why we are getting the answer negative. So children, like this numericals you have to practice, because this numericals, if you do, then your concept on thermodynamics will get clearer. So this much for now. Today you will practice on this in your class. Bye bye.